Okay, YouTube, in this vector application problem, we're just going to be given certain information about its direction and its magnitude. And in this case, we're just after the vertical and horizontal components of the vectors. I don't want to sum anything here. I just want to find its components. So let's go ahead and read through the situation here. It says a gun with a muzzle velocity of 1,200 feet per second. So we have a velocity here, which is going to kind of represent the magnitude or length of our vector here. 1,200 feet per second. It's fired at an angle of 6 degrees with the horizontal. So we want to find the vertical and horizontal components of the velocity at its initial time, which would be right when it was fired. And neglect gravity. We're going to take gravity out of the equation and say just initially, what were its vertical and horizontal components? So to what extent was the bullet moving upward, and to what extent was the bullet moving horizontally? So given these two things here, we say this 1,200 feet per second. Let's say I have a vector here, and we're going to refer, let's call it B, the bullet vector. And we say that B, what do I know about B? Well, I know that the magnitude of B is equal to 1,200, and we can write feet per second, feet per second, but it's 1,200 nonetheless, okay? And we say its direction angle was 6 degrees with the horizontal, so we've been given this. And I also want to sketch this situation here. I want to say, well, what would this look like given that maybe this is the origin right here? So now I'm going to exaggerate a little bit, but it goes boom, like the sound effects there. And so if we were to represent this with a vector, we could say that this is our bullet vector, and that it has a total length of 1,200, okay? And we would say that this direction angle right here is 6 degrees. So what we're trying to do is we're trying to say that if I know that this has a length of 1,200 out here, we say that the magnitude of B was given. This was 1,200. Could we work backwards with this angle and this magnitude to find the y component and the x component of this vector? And of course we can. As a matter of fact, we could say that in any general instance, we say that the magnitude of the vector v, magnitude of v, times the cosine of our direction angle with the positive x-axis, and the magnitude of v times the sine of the direction angle with the positive x-axis. This is always going to give us the component form of this vector. And so honestly, we could just say that this is my x component and this is my y component. So I hate to be so underwhelming on this problem here, but if all we want to do is find the components of this vector, that's all we want, then we can say, well, we're pretty much done, because the horizontal component is going to be 1,200 cosine of 6 degrees. And the vertical component is going to be 1,200 sine of 6 degrees. So this is exact. This is what I want to point out first before we go find approximate values. But also that I also want approximate values. Like x, I can imagine x being a very long number here, close to 1,200, but not quite 1,200 feet per second, and then y being slightly less. So, or slightly less, much less. Okay, so we'd say, all right, well, the cosine of 6. Let's start with this. So clear 6 cosine. So we have the cosine of this, and we take that times 1,200. And we get about 1193.43. So 1193.43 is our horizontal component. And then for our vertical component, the sine of 6 should be rather small. And then take that times 1,200. And so we get a vertical component of 125.43. 125.43. So now, I actually want to comment on this before I kind of peace out on this video here, but this is all we were looking for. In filling these things in, we say 125.43, and we knew that this is 1193.43. The idea is that now that I know the horizontal and vertical component, if you were to see somebody fire this gun, then you would observe this bullet changing horizontal direction with respect to you at this speed, feet per second. It's not going the true 1,200 feet per second that it's getting fired at, because that 1,200 is being used to go in this 6 degree elevation from the horizontal in this direction. So it's going 1,200 feet per second in this direction. But with respect to if you were standing face on with this situation from the side, and you looked at it horizontally, it would be going about 6.57 feet per second less. Because of this angle here. And then likewise, we would say, well, if you were to measure how far is this bullet traveling just purely from the ground, from the horizontal, straight up, and it wouldn't be going 1,200 feet per second, because of course it's going 1,200 feet per second in this direction here, but going upward from the muzzle of the gun, which is parallel to the ground, we'd say it's going up at this many feet per second, a much lesser rate. And you could increase that by, you know, tilting your gun backwards more. You could say maybe it's fired in this direction, and you would have something like this, okay? But the idea is, again, if you have the angle, the direction angle, not just any angle, but the direction angle, and we have the velocity or force or magnitude, then we can always just write the component form fairly simply, and then even convert that to decimals if we need to. Cheers.